Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our research report on wind vector anomaly in the maritime continent of Indonesia, its impact on local environmental sustainability in West Nusa Tenggara. This finding was reported by Mr. Mahrup. He's on my left-hand side. Myself, Dr. Kusnartha, Mr. Soemeinaboedhy, Mr. Fahrudin on my right-hand side, and Mr. Padusung. We are all the faculty members of Faculty of Agriculture, Department of Soil Science, University of Mataram, Lombok, Indonesia. As introduction, I would like to mention that ocean surface winds is one of the most important factors regulating global and regional climate. As the largest maritime continent in the southeast Indonesia, has very complex climate regime, according to Chang in 2005. Its geographical position between two continents, namely Asia and Australia, and two oceans, namely Indian and Pacific Ocean, make it high climate variation. Anomaly of wind direction in the Colburn zone result in an erratic climate type, result in a significant impact on climate conditions. Here, the pictures indicated that in normal situation, in normal condition, it's common that winds from north, from Pacific region, move to the south, passing equator, and reach Natuna Seas, and then in Java Seas, the wind turn left and move along northern coast of Java and Nusa Tenggara, bringing water vapor and creating rain. The similar things happen with west coast of Sumatra. The wind moves to the south of southeast, and then when it reaches South Indian Ocean, it turns along the south of Java and Nusa Tenggara Island. This wind also bringing water vapor resulted in wet season in the region. Different things happen in the anomaly situation. You can see in this picture that wind of South Indian Ocean, instead of moving to the north, it moves to a different direction, which is northwest. The same thing happened with West Coast Sumatra winds. On the other hand, Natuna Sea winds move direct away, leaving Indonesia region. And this is bringing water vapor away from Indonesia and resulted in drought in Indonesian region. The methods of our research, this research is a descriptive research. It was carried out with 3 steps. First, secondary data collection, for example, rainfall data in West Nusa Tenggara, and wind vectors at South Indian west coast of Sumatra and Natuna Seas. The second step is data analysis, the calculation of standardized precipitation index, SPI, and identification of wind vector direction. And the last is the interpretation of data. For example, standardized precipitation index, SPI, was classified into 4 categories for drought and fall or wet. Statistical analysis was carried out using time series event of wind vector anomalies and was determined by a run test at 5% significant level. The test for dependency between rain event and wind vector directions at locus of anomaly using independence test, C-square test at 5% significant level, 2 degree of freedom according to Walpole 1974, and formulated as follows. C-square is the sum of observed frequency of wind direction minus expected frequency of wind direction square and divided by expected frequency of wind direction. As for hypothesis, if calculated C-square less than or equal to C-square table of 5% and 2 degree of freedom, then the hypothesis is accepted. Means that there was no dependency between rain event and wind vector anomaly. If calculated C-square greater than C-square table of alpha 5% significant level, 2 degree of freedom, then the hypothesis is rejected. Means that there was strong dependency between rain event and wind vector anomaly. Now we come to the result of our research. We observe long-term standardized precipitation index SPI in Lombok during growing season November to April within a period of 1983-84 to 2018-2019. From this figure, we could observe that during that period of time, it happens that some cases there is SPI positive, and in most cases happen that SPI is negative, indicating the drought season occurred in Lombok Island. The most severe event of drought occurred in 1986-1987. Similar thing happened to Sumbawa Island. This is even more severe, the drought in the Sumbawa compared to drought in Lombok. In very less cases, wet season, wet condition occurred in Sumbawa according to the standardized precipitation index SPI data. And we observed in the Sumbawa Island from 2004 to 2005 till 2018 and 19. This picture indicated that the frequency of wind vector anomaly at 3 locus inducing drought in West Nusa Tenggara, that South Indian Ocean have the same effect both in Lombok and Sumbawa. Differencing happen with West Coast Sumatra. Lombok more affected by the wind rather than Sumbawa. However, the wind in Natuna seas affected Sumbawa more than Lombok. Probably these differences would be due to the effect of Rinjani mountain effects in Lombok Island. If we see more detail of monthly wind factor anomalies in Sumbawa and Lombok, we could see that if it happened in November in Lombok, the probability of anomalies happen is 14% less than what happened in Sumbawa, which is 16%. If we see it in December, similar thing will happen. In Lombok 13% and in Sumbawa 14%. And it happened in other months. April, for example, the same impact happened in both in Lombok and Sumbawa. The frequency of wind factor anomalies, if we see from the month of occurring, it occurs in November, Sumbawa Island is more severe than Lombok Island. However, it happened in February, for example. Lombok more affected rather than Sumbawa. If we see the effect of different locus of winds anomaly, South Indian Ocean have the same effect both in Lombok and Sumbawa. However, west coast of Sumatra affected Lombok more than Sumbawa. On the other hand, Natuna Island, Natuna Seas affected Sumbawa more than Lombok. As conclusion, we could say that wind factor had an arbitrary characteristic might result in erratic drought in West Nusa Tenggara. Three locus of wind factor anomalies firmly associated to drought for Lombok at SOI 90 degrees east to 120 east and zonal of 8.5 degrees south, and at West Coast Sumatra between 90 degrees and 110 degrees east and zonal 0 north to 10 degrees south. For Sumbawa, at Natuna Sea, at meridian between 105 and 115 east and zonal 5 degrees north and 10 degrees north, and South Ocean India 90 degrees east to 120 degrees east and the zonal of 8.5 degrees south. Anomaly taking place in the middle growing season, particularly in February, had induced profound effect on drought in the West Nusa Tenggara region. I would like to acknowledge the Department of Soil Science, Faculty of Agriculture and University of Mataram, and special contribution is also addressed to Research Center for Water Resource and Climate University of Mataram. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Perlu diperbaiki, diulang, ya.